All right, our next topic are what are called fallacies. And a fallacy is kind of the opposite end of logical proofs. Fallacies are things that are not logically valid. And there's two main fallacies that we're going to encounter. The first one looks like this. Given that P implies Q, and given Q, we conclude, and I'm using the double arrow here to just say this implies the following. This implies P. So given that P implies Q is true, and given that Q is true, we're concluding P. And this is not a tautology. This is not logically equivalent to true. In other words, this is not always the case. And if we base an argument on a fallacy, then the rest of the argument falls apart, right? If we assume that this is true, we have something in our argument which is not correct, which is false, and everything that comes after that is suspect. So we have to watch for fallacies. Okay, this is an example of the fallacy of affirming the conclusion. And I'll give you an example of this. Let P be the proposition you do your homework, and let Q be the proposition you get an A. Okay, P implies Q is the proposition. If you do your homework, you get an A. And let's suppose that's true in this course. If you do your homework, you're going to get an A. And Q is the proposition, you get an A. Well, this statement is saying that as long as you know that if you do your homework, you get an A, which is true, and you get an A, you must have done your homework. That doesn't follow logically. It may be that you're so smart you never did any of your homework. This is true, but it may turn out that P is false. In other words, this conditional is true and you got an A, but you did not do your homework. So we can't conclude P from this, right? What we're trying to do is claim that if Q is true, then P must be true. And the arrow doesn't go in that direction, it goes in this direction. All we can say is that if P is true, right, given that this is true, we can say if this is true and P is true, we can conclude Q. But knowing that Q is true does not mean that P is true. And this fallacy pops up all the time, okay? If you're going to rob a store, then you have a gun. And you have a gun, therefore you're going to rob a store. Doesn't follow logically, okay? So this is a very common fallacy. The other fallacy is given, again, that if P then Q and not P, then we can conclude not Q. And this is a fallacy of denying the hypothesis. And how is it a fallacy? Well, let's use the same arguments here. If you do your homework, then you get an A. And you did not do your homework, can we conclude you will not get an A? No, because again, you might get an A even though you didn't do your homework because you're just very smart and you didn't need to do your homework. So this is also a fallacy. And it pops up in lots of circumstances as well. So the versions of this that we're sometimes thinking of are the following. Given P implies Q and P, we can conclude Q. That's true, okay? So this is true. And the version of this that we might be thinking of is given that P implies Q and not Q, that forces us to conclude not P. And this is a true statement. Okay, this is direct reasoning, and this is indirect reasoning, or contrapositive. Okay, so these are tautologies, these are fallacies. Okay. Alright, so next video we're going to start looking at proofs and taking all this and applying it to a number of different theorems and showing that those theorems are true.